Think about standing in a dark arcade, illuminated only by the glow of the screen as a wave of alien ships marches downward. That tension is built on incredibly simple math. We are going to capture that exact feeling by building Neon Skies. It is a fully playable, retro-styled space shooter, and we are going to write the entire engine logic inside a single file. You don't need to install any heavy game engines to follow along. If you have a modern web browser and the starter boilerplate HTML code linked below, you are ready to begin. By completing this short build, you will write the core engine logic, the sequence of drawing, moving, and checking for object interactions that drives almost every 2D action game made today. Step 1 is preparing our environment. We start with an HTML canvas acting as our deep space background. Just above that canvas, we initialize our starting values in the HTML header, a score of 0 and 3 lives. To make objects actually move, we need to create a game loop. In JavaScript, we use a built-in method called requestAnimationFrame. This tells the browser to update the screen right before the next repaint, serving as the continuous heartbeat of our engine. You must link this function carefully. If you trigger your update logic without yielding to the frame rate, you create an infinite loop that instantly freezes the tab and crashes your browser. With the loop safely running, we can draw our ship. We define it as a JavaScript object with a width, a height, and X and Y coordinates that position it right at the bottom center of our canvas. Moving that ship requires inputs. Just like wiring physical buttons on an arcade cabinet, we add event listeners to our code that watch for the left and right arrow keys. Pressing them simply increases or decreases the ship's x-axis value. If we leave it like that, holding the right arrow will drive the ship completely off the edge of the screen. To fix this bug, we apply clamping logic, a mathematical rule stating the ship's x-coordinate can never be less than 0 and never greater than the canvas width minus the ship's own width. Establishing these strict boundary limits early on is how you translate a static shape into a reliable, controllable character. Step 2 is giving our ship a way to fight back. We bind the spacebar to a new firing function. Every time it's pressed, we push a new projectile object into an active array. This diagram shows HTML canvas coordinates. The y-axis is inverted. 0 is at the top, increasing downwards. To fire lasers upward, the loop constantly subtracts from their y-coordinate. Tapping the spacebar generates projectiles that travel straight up, clearing the screen. Next, we spawn the targets. Instead of manually writing out 50 individual enemies, we use a nested loop. An outer loop handles the rows, a inner loop handles the columns, instantly drawing a perfectly spaced grid of alien objects. To make them threatening, we tell the entire grid to move horizontally until they hit the canvas wall. When they do, they reverse direction and add a specific amount to their y-coordinates, dropping them one step closer to the player. Keeping track of these two distinct arrays, the lasers moving up and the swarm moving down, creates the core tension of the arcade experience. Step 3 is making those two arrays interact. On every frame, the game needs to check if the exact X and Y coordinates of any active laser overlap with the coordinates of any active alien. This diagram shows how we simplify that math. Instead of tracking the complex outline of an alien graphic, we wrap it in a hidden rectangle called a bounding box. When the laser's box touches the alien's box, a hit is registered. When that overlap is detected, the game executes a deletion. It targets the specific index of that laser and the specific index of that alien, and removes both of them from the active arrays, erasing them from the screen. We tie that specific deletion event directly to the header UI, telling the engine to instantly add 100 points to the player's score. But the player needs to face consequences too. We write a conditional statement checking the lowest edge of the alien swarm. If any alien's bounding box crosses the player's y-coordinate threshold, the player takes damage. The engine immediately subtracts a life from the header. If those lives hit 0, the update loop is stopped, all objects are cleared, and a large game over text is rendered in the center. That collision logic is the final bridge. It turns a collection of moving shapes into a complete system with strict rules, actions, and stakes. Putting all of those steps together gives us a seamless run. The controls are responsive, the collisions are accurate, and the failure state triggers exactly when the swarm makes contact. You now have a fully operational arcade engine, built entirely from scratch inside a single file. From here, you can easily change the parameters. Try adjusting the CSS variables to change the neon glow colors, increase the multiplier for the swarm's descent speed, or write a new array that spawns a massive boss wave. Take the spaceline code, break it apart, and experiment. You have the foundational logic required to build your own custom piece for your programming portfolio.